Hi, everyone. This is an introduction to conditional property, A given B. So here's your formula for that. We're going to use that. And we're also going to talk about conditional property for independent events, I believe on a different video. And we're also going to use the addition law of property because we have to determine if R and S are independent events. So first of all, if R and S are independent events, then we should have two numbers that equal each other. The first one would be the probability of R and S should be probability of R times the probability of S. We know that that's what this is. So that's just going to be 0.4 times 0.5, which equals 0.2. So now to determine if they're independent, we're going to use this information and use our addition law of probability. So we're going to use probability of R and S equals probability of R plus the probability of S minus the probability of R and S. So let's fill everything in. We know this is 0.7, that's given. 0.4 plus 0.5 minus probability of R and S. Keep in mind these two are the same. So they have to be the same before they're independent. Now, so we get probability of R and S equals 0.4 plus 0.5 minus 0.7. This equals 0.2. These two numbers match. So this question should be answered with a yes. R and S are independent events. But you have to do both formulas here, given the data they gave us. All right, we got another example here. And at the end, we have to find if A and B are independent. We could actually do that now. So let's go ahead and see if A and B are independent, just like we did on the previous slide. So probability of A and B equals the probability of A times the probability of B. So that's going to be 2/5 times 1/3 equals 2/15. Now we're going to find this to see if it matches this. See if these two matches given the data that they gave us. So we know, let's write our formula, probability of A or B equals probability of A plus probability of B minus probability of A and B. All right, so we have 2/5 plus probability of B is 1/3 minus probability of A and B. We know that this equals 1/2. So we're going to take probability of A and B equals 2/5 plus 1/3 minus 1/2. I just rearranged the equation. Now let's simplify this fraction. Our common denominator is 30. So to simplify this, we'll multiply this by 6. That gives us 12. 3 times 10 is 30. So plus 10 minus 2 times 15. So multiply this by 15. And when you add this up, you're going to get 7 divided by 30. So that's what probability A and B are. These two numbers do not match, so you're going to write no. They are not independent events. So our official A and B is 7 divided by 30. All right. Now let's do the next one. We're going to do probability of B given A. So we'll write this down as probability of B given A equals probability of B and A divided by probability of A. So we already know what this is. It doesn't matter if you write probability of A and B is the same as probability of B and A, because you're just multiplying. So this is going to be 7 divided by 30, and the probability of A is 2/5. So simplifying, you have 7 divided by 30, and we have a complex fraction. So let's just write it like this. Remember, in grade school, you would do this. So 5 goes into 36 times. So this is going to equal 7 divided by 12. All you have to do is multiply these two together and these two together. Now let's do the next one. It's this one. So for that one, we're doing exactly how the formula is written. A given B equals probability of A and B divided by probability of B. So we already know that this is 7 divided by 30 for the numerator, and the denominator is going to be 1/3. Again, that's 7 divided by 30, and then write times and flip this around. 3 divided by 1. So 3 goes into 30 10 times. So this is going to equal 7/10. And again, we already did this one. Are they independent events? And the answer was no. And that's it. Thank you. Have a nice day. Bye-bye.